Hi, everybody. Mr. Samuelis here. Sitting here waiting on a discrete meeting for any student to pop in. Of course, nobody has. I don't think I've talked to somebody for a week or so. It's okay, though. But we have those options out there as always on a daily basis if things get a little rough. So I thought I'd show my face that I'm actually here waiting for you. Um, and then we'll disappear that and we'll continue the notes. By the way, the camera, adds 15 pounds, so but also so does snacking all day long because of boredom. So, but anyway, let's get going here. All right, yay, new notes. All right. So today I am actually going to do three methods in one because they're all the same as far as their process is concerned with a beginning different step. And then that's what our week will be, just dealing with those three in addition to the two last week. Um, then we'll tie up the chapter next week um, with one more method, the one that we actually use to this day. Okay, so if you remember that historical document that I did with the Hamilton method, and then just for giggles, the Lowndes method, and use that as an instruction of the Lowndes method. Um, what was actually used first, which was called the Jefferson method. Yes, that's Thomas Jefferson. Okay, so look at this example again. This is the same one from your original notes. The same exact start with these 6 fantasy states. And had a population of 18 million, I'm sorry, and they want to apportion out 300 seats. So in all three of these next steps, they are still the same start. So that's why, giving you a second to write this down. The very beginning step is exactly the same. Take your populations and divide them by what's called the standard divisor, which really what it represents. Again, if there's 18 million people and you want 300 or legislators, very easy for me to say. When you divide these to 60,000, that means one rep will represent approximately 60,000 people. Um, Approximately, but then we got to make changes based off of whatever method it is. Okay, here we go. I'll tell you what a divisor method means in a minute. Well, it's actually up here, and it's the same for the other two methods except for step one, how they decide to round. But a divisor method is not what we had last week. Hamilton and Lowndes are called quota methods. They divide by the 60,000, you get a quota, and then you just assign extra seats after that based off of either fractional part or relative fractional part. That is Hamilton and Lowndes, respectively. It's exactly what you do in those two different scenarios. Where here, it's called a divisor method because after you fail on the first rounding, or if it doesn't work out, you change the divisor until the apportionment is met. And I'll show you what that means. That's all three methods today. But first method is Jefferson, where you do exactly what you did with Hamilton. You round down. Okay, now we have to understand every time that we rounded down, that means 43.9 goes to 43. You just lop off the decimal. 82, 50, 50. By the way, I run the risk if a student comes in a little bit late on the notes. I don't know why I didn't do it last night, but a discrete student could pop in during this note session. Great. 3, 4, 5, 6, 7. Yeah, 297. So you're short. All right, and then I told you and mentioned this in the apportionment of the United States legislature. I was going to show you we should actually type these numbers in the L1 screen because in this whole set of notes I'm going to use these numbers over and over and over again. I'm going to mathematically do things with it. So the first one was take, so you put everything in L1 and then it does the number thing, the scientific notation because the numbers are large. But the first one's 4,300,000. It is still 325,000, but it just shows it in rounded form when it does scientific notation. Anyway, once I get these in L1, then I go to L2's name, and I type in L1 divided by 60,000, and that divides all of L1 by 60,000, and there you go, you see your numbers: 72.1, 43.9, 82.8, 50.7, and then 50.5. I rounded to the nearest tenth. Sorry, couldn't think of my words. All right, so we obviously see that, and I'm going to leave that one and then go to L3 when I do any other calculations. So we are low. So what we need to do now in all of these methods is deal with what's called a modified divisor. And then I'm going to call this, usually, on a test, you're just going to do trial and error with your calculator. Back in the day, I used to make people write their modified divisor down. But I want you to write down the one that you find a success with, and I do want you to use your calculator. All right? So let's think this mathematically. I have to modify this 60,000. I have to change it so that I go back and divide these population numbers by a different number, and I need this to go up to 300. So what would I have to divide by? A larger number or a smaller number for this 297 to go up? And the answer is a smaller number. You want to divide by a smaller modified divisor. Now I'm going to write my modified divisors down here. I think I have room for it right here. Now I'm going to try 58,000. So all I have to do is think mathematically. Now, you don't have to do this. You can trial and error, but what I want you to do is identify the divisor that worked, and there's always going to be a range. There's going to be a range, and when it comes to a test, I will have that range figured out, which ones will work and which won't. So, there's nothing to it there. So I'm going to try 58,000. So that's why I like the calculator. So I'm going to go over to L3 and divide. Sorry, I didn't even tell you probably where L1 was, just to remind you, it's second one. So there's L1 divided by, let's try 58,000. Enter. Now what we want to do is look at this and do our rounding down. Okay, so what do we need? We needed 3 extra seats. Okay, so now when I look at these that were rounded down, look at how bad this 58,000 was. 74.5 goes to 74, so that's 2 extra seats. 45.4, 2 extra seats. We're already over, and there's only going to be 1 seat given extra compared to the original apportionment. So I was way off. 58,000 was not a good one. 85 is 3 above, because we're still going to round down when we do this. 52 and then 52. So I added 2, 4, 5, 6, 7, 8, 9, 10, 11 seats. That would be, I can't do math right now, 308. Ay, that's awful. So when I go back and, back in the day I would have had you write those numbers down. But for time purposes, I'm going to show you how, we're going to streamline this. I don't even think 59,000 is going to be good. I'm going to try L1 divided by 59.5 maybe, because that was just way off. Oh boy. One more. 59,500. Remember the original was 60,000 and I went to 58, and this was just way bad. And I hope you get that was really not good. I don't want to see that anymore. Okay, now maybe a chance to be excited. Look at the original. So that stays at 72. 43 turns into 44.2. 82 turns to 83.4. That's 2 extra seats. Boom. Anyone? Shakalaka. 51.3. So I'm going to go ahead and write that one down. My modified divisor was, what I tried was 59,500 instead of 60,000. And I ended up with 72.6, which is still 72, or 72.7, which is still 72, no change. Wish I could stay up here. Let's see if I can do this. Maybe I will. 44.2, that's up 1. So that's 44. There's 1, and I'll highlight that later, the change compared to the original apportionment with the original numbers. 83.4, actually really 83.5, but doesn't matter. It's still 83, which is plus 1. And then 51.1, which is 51, another plus 1. And then 50.9, whoo, almost, but not quite. It stays at 50. And I'm going to highlight. These were the increases in seats. And when there's an increase of 3, boom shakalaka, that is 300, which is the apportionment that we're looking for. So it's a trial and error. And ultimately what I want you to write is what is the divisor that worked. And then again, there will be a range. I bet you 59,600 would probably work, possibly. I'm not going to go and test that. We found something that was good. So we'll leave it at that. All right. So divisor method, you modify the divisor till you get a hit. But let's remember what the Jefferson method is. Round down first. See that you're low. So then you modify the divisor by decreasing it so this number can increase. And that's what's going to go on there. Okay. Set up the divisor method. Now let's look at 2 other characters that lived the same time as Jefferson, and these were bounced around. Webster said, well, what are we doing this silly rounding for? We're mathematicians. Let's round mathematically. Let's look at the initial quota. Look at those decimal parts, what they call fractional parts, and just round mathematically. And then maybe we'll end up hitting something right on the dot, maybe not. But if we don't, then we're going to modify the divisor. So here's the first difference with Webster, and you just have to have these memorized, our little game that we play. This rounds to 72. This one, this is where the difference comes into play. This one rounds to 44. This one rounds to 83. This one rounds to 51. You know what? I'm going to check that 50.5, because if that was 50.4 something, then that would actually go down to 50. Nope, it was 50.508. So be careful on that. If this was 50.47, that would round down to 50. But it wasn't. It was 50.508. So this is 51. Bummer. We were close. 6, 7, 8, 9, 10. This is 301. Only in Webster's method, when you round mathematically, you could, the only method, you could end up getting right on the dot what your apportionment is, because some may round up, some may round down, and it may hit that 300 right on the dot. So close. But you know what this is? It's a little too large. Look at how much I only had to go down by 500 to make Jefferson's work, and change 3 seats. This one's so close, and as a matter of fact, 51 was so close to rounding down that we're barely going to have to modify our divisor. But what do we need to do? Do we need to divide by a higher number or a lower? And the answer is you divide by a higher number to decrease these apportionments. And I'm serious. I'm going to go like 60,000. I'm going to try 100. Because this already, I feel like this is the one that's going to lose out. So I'm going to go to this. I'm just going to keep changing L3. Seconds, L1 divided by, not 60,000, 60,100. That will decrease the decimals, dividing by a larger number. And then let's see what we end up getting. Well, there's that 50.4, just what I thought was going to happen. 43.8 still goes up. And what's interesting about the Webster method, since we round mathematically, 71.9 still rounds up to 72. So that one didn't change. 43.8 will still be 44. 82.6 will still be 83. 50.6 will still be 51. 50.4 now goes down to 50 because of mathematically rounding. So I'm going to go ahead and write those down. I guess I'm switching sides here. All right, so I do want to write the decimals down now. 71.96 is still 72. 43.8 is still 44. 82.6, because Webster rounds mathematically, is 83. So these three didn't change. 50.6 is 51. And then 50.4 is 50. And I'll highlight that one, that was, I needed a change, and that was the change to knock this down to 300. All right, so now I got 300 seats apportioned, and then yet again, there would be a window of numbers that would work. 60,200 might be all right. You know, I don't know. Might be kind of a small window. All right, so Webster, you round mathematically, you modify the divisor. Last one, I know these are silly, like seriously, this is what these founding fathers came up with. This is absolutely 100% historically accurate. What Adam said is, wait, this is weird. Since you're rounded down, you're rounded mathematically. What's left is to round every number up. So let's do that. 72.1 goes to the next integer, 73. 43.9 still ends up being 44. 82.8 ends up being 83 because you just bump up to the next decimal, or whole number, I mean. 51 and 51. You're not rounding mathematically. You're rounding up. You're just going to the next higher integer that the decimal is in between. So of course you should understand you're going to be always over in the first apportionment in the Adams method. 7, 10, 11, 12. So we're 2 over using the Adams method. All right. Okay, so we're going to start by, and I think I already did it, but I'm going to go ahead and do it again. I'm going to try 60,500. Again, reiterating, I want 302 to go down. So what I have to do is increase my divisor so that the numbers decrease decimally. It's just a simple mathematical concept. Okay, then let's look at this. I need to decrease by 2 seats. 71.4 will go up to 72. There's a loss of 1. Good. 43.5. 44, no change. 82.099 is actually going to go up to 83, no change. And then the 50s are going to go up to 51 as well, just because the Adams method, no matter what the decimal is, you go to the higher integer that it's between. That's his situation. So 60,500 almost worked. So I'm going to do 60,600. Hopefully it's not so picky that 2 of them change, and we'll check that. So 60,600. 71.3 is still 72, a loss of 1 still. 43.4, no change, 44. 81.96. That will go to 82. That's our second loss of a seat. And then 50.2 goes to 51. 50.008 actually goes to 51. So nice. So I'm going to write those down. First of all, I want to write my divisor. The modified divisor was 60,600. Right? And that's what I mean about mathematically. You're just getting to work with what number works to make this happen. All right, then I got to split the screens here. All right, so just to mark down, it was 71.4 we could write. That goes to 72, and I'll mark the losses. That's going to be marked highlighted. 43.48 still goes to 44, no change. Here's our change though, 81.96 goes to 82. There's the second loss of a seat. And then the other one's no change, and that's what I'm looking for. 50.2 goes up to 51 with the Adams method. and then 50.008. Still 51. Highlight the two losses. Loss of 1, loss of 2. 302 divided by 3, or divided by minus 2 is 300. Right on the dot, the apportionment that we want. Okay, so divisor methods. And then when we scale back, look at the different methods gave different seats to particular states. 72, 44, 83, 51, 50. This is 82 and 51, and then 72, and then still 51. So you're getting different apportionments with the different methods. Definitely. Yep. So we get a different scenario there as well. 72, 44, 83 hike. Yeah. So it's a little bit different there in each scenario. So all these methods were discussed. Actually, the three that we mentioned today, I believe, have all been used at some point in history. And you'll see that with a historical document that I have stolen off the internet yet again years ago to show the history of the apportionment methods, which we'll do next week. All right? So hopefully that is good. We only have one more method next week, and we'll close out this chapter next week.